Pablo. I'm the founder of Zenva, an online academy that teaches coding and game development. Virtual reality, the ability to be present and to experience worlds that don't exist, is a very exciting topic. And the main way that we interact with these virtual worlds is by using hand-tracked controllers. When it comes to developing apps that make use of these controllers, there are different platforms, and it is a very fragmented ecosystem. Different manufacturers have different SDKs. So until recently, if you wanted to develop an app in Unity that made use of these controllers, you had two choices. You had to either install a third-party library, a third-party SDK, a proprietary SDK, in which case your application would only work in that SDK, or you had to either develop or use existing third-party frameworks that sort of group together some of these proprietary SDKs and allow you to switch between them, but those frameworks were not always well maintained, so it was very painful. Luckily for us, this has all been made a lot easier with Unity 2019.1, especially with the new XR input mapping system. So what we're going to be talking today, we're going to start by talking just about general tracking in virtual reality. And then we're going to go over the new XR input mapping system. And we're going to end up with a couple of examples. All of the code is on GitHub already, so you'll be able to get that as well and use it as a starting point if you want to create some simple controller-based VR experiences that don't require proprietary SDKs or frameworks that include a lot of other things that you might not want in your project. So if I'm playing a game in my laptop, what happens if I move the screen? Well, of course, nothing. The view of the game remains the same. So that is the main difference to how the camera works in a non-virtual reality application than how it does in a virtual reality application, where the camera movements are not controlled by the mouse, the keyboard, or some cutscene cinematographic logic, but it is the user who is controlling where the camera is looking at by simply looking at that direction. So it is the headset device that tracks the rotation and, in many cases, the position as well of that camera. When it comes to hand-tracked controllers, it's the same thing. The position and rotation of those controllers, when supported, comes from actually the tracking system. So these are not things that you can just change via code. You can't force somebody to look at a certain direction. Now, how we set this up conceptually, there are cases where we do need to move the player around. Let's say you go in a lift or hop into a vehicle. So then what you do is you set up what's called a camera rig or an XR rig. That is a containing object for your camera and your controllers. So if you need to move your player, user, you just put that entire thing inside your vehicle or inside your lift. And inside of the camera rig, you will have the camera itself and the hand-tracked controllers. Now, there are different ways to define and classify VR experiences, but a common one is to talk about stationary experiences, which is when you also need to sort of indicate where the floor is located, because the tracking system doesn't know where the floor is located, for example, the Oculus Go. So inside of your XR camera, you will have like a floor offset object that will lift that up. But if you do have the full tracking of your environment, that's a room scale experience, and then that floor offset is not really kind of needed. But if you want to go cross-platform, you probably do want to have a setup like this. How you set this up in Unity is pretty simple. Basically, these are all empty objects inside of one another. The head is a camera. And for the tracking itself, we're using the tracked post driver component, which is a native Unity feature. It no longer comes in 2019.1. You have to bring it in from the package manager. It's called import XR legacy input helpers. Now, you see the word legacy, and obviously freaked out at first, but I've confirmed the forums of Unity, and that is really the latest component you can use to track the position and the rotation of the camera and the hand controller. So that gives you an easy-to-use component, and with that you can have the basic tracking working, which is already a good starting point in a lot of cases. That might be enough. But now we obviously want to go beyond that. And this is when the new 2019.1 XR input mapping system comes into place, which is I want to be able to detect the pressing of the different buttons in my controller. So the Unity manual already has this new system. Basically, a new set of what's called standard feature usages is defined, so that in your code, you target, let's say, the trigger. And you have a trigger button in different controllers. And so in your code, you just focus about, I'm using the trigger, or I'm using the grip button, or I'm using one of the other buttons. And those buttons are mapped in all of the different, in all of the main platforms. And this supports out of the box all the main platforms, so Oculus, OpenVR, the Windows Mixed Reality headset as well. So now something that's important to mention is that some of these buttons are referred to here as buttons, and they have a value of either true or false. Like you're either pressing the button or you're not pressing the button. But some of the other buttons are axes, and that means that they have a value between 0 and 1, and it's because you can press it just a little bit or all the way. So that's, if you press it all the way, that's 1. And then you also have some that are 2D. For example, like a lot of the headsets have this sort of 2D, like a touchpad area, so you can use those as well. And all of that without installing any external SDKs or without having to set this all up yourself, like from scratch, which was the case before. So let's look at just a hello world example of the XR button. Basically, the way that this works is that you get the device that is in your, you tell Unity, get me the device that's in my right hand. And then are we pressing the button? If that's the case, then we can run our own logic. So if we look at some code, and we basically start by getting the devices that are either left hand or right hand, it's called the roll. And then we go over all of these devices. We check whether the button is being pressed and whether the value of the button is the value that we want it to be. So then we obviously want to make this a bit more reusable so that we end up with something like this. An easy to use component you can drag into any game object. You specify what hand you want, you specify what button you want, and then you can just add, with Unity events, you can easily add an action to be executed when you press the button and when you release the button. So you can ignore that code that I showed before, or you can ignore all code if you want. You can use these components, and then you've got out-of-the-box support. So you can get the source code there as well. And it's on GitHub. There's a link there to GitHub as well. Now we talked about axis as well, which is when it's not just it's not like binary. It's either pressed or not pressed. It's more like maybe I press a little bit. So the way that we can work with those is that we can define a bit of like a limit and say, okay, I want something to happen. I want to shoot this gun or something when I press it maybe halfway. So you set a threshold, and we can create a component like that that works similar to the previous one, but that gives us a threshold value that we can move between 0 and 1. And then we can do things when the button is pressed, which is when we've crossed that threshold, and also when we release it. So if we have a look at the code of that, again, don't worry about the specifics. We start by getting the devices with a certain role, which can be right hand, left hand, and there are also some other roles like for cameras that might be in your track scene, or by custom tracking devices that you might build. It can be supported. So you get all the devices, then you go through all of them. There's usually going to be just one, or in most cases, it's going to be just one. You check whether the button is being pressed and whether it is the axis, should say, instead of button, and whether it is greater than the threshold, which is the number I defined before to indicate that the trigger is now, the action should happen. And if it's pressed, then you just invoke that Unity event, so you can put any logic you want. So this is what it looks like for you on the editor. It's pretty easy to use, and you got axis support. Then the other aspect has to do with two common interactions. So let's start talking about grabbing first. So how are we going to implement grabbing? Let's say I've got the controller. and I want to grab this object here. So the first thing that we're going to do is that we're going to define what button we want to use for grabbing objects. And most VR applications use this button here on the side. It's usually called like the grip button, and Unity refers to it as the grip button on the manual. So we're going to check whether we are pressing the grip button. If we are pressing the grip button, we're going to check whether we are in the same area as an object that we want to grab. And for that, we're going to need to tell that object, hey, you're an object that can be grabbed. And if we do that, if we make that action, then all of a sudden, the object we're grabbing becomes like a child object of the controller. And so we can move it around. So we pick that box, and we are moving it with us with the controller. And then when we're ready to release it, all we need to check for is just that the grip button is being released. And in that case, different things can happen. It's up to us, really. We can make the object just fall to the ground like that, or we can allow us to throw it, which we'll talk about later. Or you could also have a situation where you release the button and you just want the object to go back to its original place, which can be some kind of use case, right? That you take some object and you look at it and then you release it and you just want that to go back. So you can do all of those things. Like how would these controllers look like? We need two. We need one for the objects and one for the controller. So for the controller first, firstly, we're going to add that grab controller to our hand track controller, and then our button controller, which is the one we developed before, can also be our axis controller. All we need to do is just say what's going to happen when we press, which is that we're going to call this grip method, and when we release, we're going to call this release method. And then the items themselves, the items that we are going to be carrying around, they need to know that they can be carried around because they need to have some logic as well and some different options there. So I've created this grabbable script. So you give that to your box. It needs to have a collider so that it can detect collision. It needs to have a rigid body so that we can throw it and stuff like that. And we can say options. For example, maybe if I take I'm not going to use the example of the gun again because I don't want anything to be about shooting. But let's say I grab this thing, and in virtual reality, it would be a bit hard if I grab this and it's facing the other way. It's like I would have to kind of, because I don't have my fingers in virtual reality or my tactile. So it is common that you'll just want things to face forward. So you say you grab the gun, and then the moment you pick it up, it's facing forward, so you're ready to shoot something. So we can easily add an option like that, and then we can add what happens when we release the option. When we release it, it can do nothing. Just leave it right there. It can go back to the origin, or we can throw it. And I've added some events here as well. Just like when we grab something, we can put anything here. So we can make it change colors, or make it play some sound or some animation. Same thing when we release it. Something can happen. Maybe you grab something and that triggers some kind of narrative in your game. Something shows up and says, okay, you've got the magic sword. So you can do that. Now when it comes to throwing, and I'm happy to show the code as well of the grabbing if we have time. When it comes to throwing, there's something we need to be doing, because if we just leave the object where it was, even if it has physics, it's not going to be thrown. So what we need to be doing is we need to keep track of the velocity of the controller, so that when we release the object, it will be thrown on that vector velocity. It will be given that velocity. So we need to keep track of the controller velocity. We need to check for when we release the button, so we're throwing it. We need to set the item to non-kinematic, so it's got physics, reacts to gravity, forces, and we apply that velocity. So the way that we can do that is we can first keep track of the controller velocity, and we do that by checking the velocity is distance divided by time. So all we need to do is just change the distance between between now and the previous step, and divide that by time, and that gives us the velocity. And we also keep track of the previous position so that we have it next time to compare it with. So we're always we're doing that only if we're grabbing something, and if we've said that this object will be thrown. And then when we throw that object, all we need to do is just set it to non-kinematic, make sure that it's reacts to forces, gravity, and then we give it the corresponding velocity. And so what I'm going to do is just quickly open the code of this part. But basically, the grabbing functionality, and it needs to have. I'll explain while this loads. Needs to just check so that when you go and try to grab the object, we need to check a flag that it's not already being grabbed. And if that is the case, then we grab it, and then we need to make sure that that flag is set so that we're not kind of re-grabbing things, so we're carrying them around. And then what can also be added to the system is, which I'm going to bring back while Unity loads. What could also be added is a use action, so that we could have a different button. If you want to do things for different hand controllers, you can just add multiple of these button controllers. So you can add one that, let's say, checks for the trigger, and when you press the trigger, it takes the grab controller, it checks whether this is being grabbed, and if that is the case, then we can, if we press the trigger, we shoot the gun. So the project here that you guys can download has just a bit of like a simple example of this behavior. So it has a few cubes that are grabbable, and then it has the XR rig that I mentioned before. That one has the floor offset and the head with the tracked post driver. The left hand and the right hand both have the tracked post driver. And what I also didn't mention was the model of the hand. It's just any 3D model that is placed inside of that empty object. So now let me just quickly open the. Yeah, so the grabbing, can't really increase the font size of the laptop, but basically we want to keep track of whether we are gripping, and if we are carrying something, we keep track of that element. So when we check for collision. And if we are indeed colliding with some object that can be grabbed, and we are pressing the correct button, then we just call it grab action, and then with that grab action, we just set this flag to true, and then when releasing, all we do is just set the flag to false, and then we call the release method on the item that's being grabbed. And lastly, I will show you the code of the object that is being grabbed, the grabbable object, and so all this is it checks it keeps track of the control velocity, as I have mentioned before, and then when we call this grab method, we keep just the original location of the object and the original rotation in case we need to return to that same position. And if we need to face forward, we make it face forward. Like I said before, if you grab the gun, you probably want the gun to be pointing at the right direction you want. And lastly, oops, it seems that I can. And lastly, we make it a children of the controller, so that the control can carry it around, and we make sure it's not reacting to gravity. Otherwise, you try to grab it and it falls. it's not even going to lift. Like it's just going to stay on the floor because there's no forces pushing it up. And then lastly, when we release the element, it's sent back to its original parent, and its kinematic properties restored. And depending on the release action that we decided, which was either go back to the origin or being thrown, it will do the corresponding action. So back to the origin, it will simply set the position back to the origin, and throwing the item will pass on the velocity of the controller. So to summarize, we have looked at how basic tracking works, so how you can get the headset and hand track controllers to be tracked in position and rotation out of the box without SDKs, the new XR input mapping system, and we've made this into a couple of reusable components that you can just drop into your project and start using them so you don't have to code them again. Obviously, you can extend them in any way that you want. And we looked at two common interactions that account for a big majority of the hand-tracked actions, because then you can also have other things like detecting touching, but that's it's just the basic collision detection. So if you have any questions, I'm happy to respond them about the XR input mapping or any of these related things. Yes?
It's great, thank you. Are there also something for teleporting already scripted?
Yeah, so for teleporting, what you want to do is that you want to set first. You want like a laser pointer, and the way to do that is you can do a raycaster that leaves from the controller in the forward direction, and wherever it finds, you can set an area. Let's say I want to be able to move around this area, so I set a plane in this area, and I give that plane like a teleportable target type of component. And so what I do on my controller is that I do an raycaster. If it hits an object that is a target, then if I press the button, it will give me the position of that target. So that is actually a good suggestion that I might add to the repo as well, because it is definitely a common use case. Any other questions about any of these subjects, or how the what the changes, how the old system work with the new system?
Does the Unity 2019 do the mapping automatically for you? So you just select the type of controller that you have? You have to do the manual mapping.
Yeah, no. So the old system before 2019.1, it didn't have anything like this. Let me bring that back. So there was nothing like this. You had to create this yourself. You had to go into input mapping, and I'm going to call this trigger, and that's going to be button 8 or button 10 for this other headset and so you had to create all of that yourself. And then once you had it, it was not like it wasn't difficult to use. It was just checking for input, same as fire button But with this is much easier because you have the more like standard ones, and it tells you, okay, Windows Mixed Reality, that's the joystick. The Oculus, this is the joystick, and it's got the table keeps going there, and you got a whole bunch of other headsets, Daydream, Oculus Go.
Do you able to add like custom ones, like you have Bluetooth controllers that you use into Fire or something? Can you add custom ones to connect to one buttons?
I know that there's one aspect here, which is when you check for the devices, you check for the input device role, and there's left hand, right hand, but then there's two that are additional. One is called tracked, and the other one I can't remember, but I think there's an API so that you can hook onto those custom ones and then send the events. Awesome. Well, thanks everyone, and if you have any more questions, just come to me afterwards if you see me. Thanks so much.